So here we are on page 182. We are looking at different ways to express area. Here we see a pretty complex figure. So just by looking at it, it looks like G is representing an unknown amount of feet. There's a shaded area. So it says a construction company builds 5-foot wide walkways. So that's probably the green frame, right? Around square gardens of different sizes. Now, this isn't just perimeter because it has a width to it. It goes two-dimensional. It's not just a single line. Write an expression for the area of a walkway around a G foot by G foot square garden. So I'm going to put a little check mark here because that tells me I read it once. I'm going to read it again. A construction company builds 5-foot wide walkways around square gardens of different sizes. So that should tell me the white area might change from time to time, and that's why it's represented with G. And I know that the area of a square or a rectangle is base times height, or length times width. Write an expression for the area of a walkway around a G foot by G foot square garden. Okay, I read it again. Now I'm going to look for specific information to help me focus. 5-foot wide walkways around a square garden of different sizes. Write an expression for the area of a walkway around a G foot by G foot square garden. So there's a few things I can do here. I can break this walkway into rectangles and solve it that way, and then multiply by how many of those I create. It doesn't look like we can really subtract anything, although, I'm not seeing it in my answer key, but let's try that. So there's a couple of things. We could divide it here and here and here and here, or we could divide it here, Let's divide it this way. So I'm going to draw a line here and here. So that means this long section. And I'm going to divide it here and here. So I have two longer sections and two shorter sections. So this would be 5 feet by G plus 10. Two rectangles that measure 5 feet by G plus 10, because you have to add the 5 on each side. And two rectangles that measure 5 feet by G feet. So these two rectangles don't have to add the extra space on this side because I cut them off here and here. The total area would be, in this case, would be 2 times, I can use a bracket. So I'm going to have G plus 10. So if I'm just thinking about these two, the long ones, I could say that it's the width of G feet, plus 2 chunks of 5. So it's actually 5 and 5 here and here. So that makes it 10 G plus 10 times 5. So I could say 5 times G plus 10. Here's a bracket. So that says we're done with this whole part. So we'd solve G plus 10. We don't know what G is, but we're just showing it as an expression. Multiply that by 5, and then that result gets multiplied by 2 because there were two sides. Plus, we're going to add the areas for these two shorter walkway chunks or sections or terms. This time it will be 2 again, but it's just 5 times g. There's no additional 10 feet on each side of this direction. It's just what's in here. Or we could write it this way. So I'm going to start another line here. 5 times, and I can put in parentheses g plus 10 plus 5 times g plus 10. Sorry, I'm looking at my answer key too, so I don't mess up. Plus 5 times g plus 5 times g. Interesting. We could have divided these here and here and here and here and made all of these rectangles the same length, and then the 10 would have changed a little bit. Oh, okay. I wondered if there was a way to subtract this. I found on the answer key there is a way. So let's write that up here. Or here's another way we could do it. I like to use the subtraction method, I guess. I don't know. We could subtract the area for g, the g by g square, from the larger outer green square. So it's like putting a white one on the green one and taking that out of it. So you would do that by saying, look at this one's shorter too. G plus 10 to this raised to the second power, because you would do it times itself minus g raised to the second power. So we could pause this and think about this, but I'm going to keep going. Number 9 is a little tricky to see here. It says each small square in the diagram at the right is 1 square unit. Write an expression for the total area of the blue part. So write an expression for the area of the blue parts, okay? Well, I'm just going to count. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. There's 21 of these. And there's 21 over here, I already counted. So together that makes 42 total. So how do I express this in a creative way? Well, I could say 1 plus 2 more plus 3 more plus 4 plus 5 plus 6. 1 plus 2 plus 3 plus 4 plus 5 plus 6. I could do that. Or I could combine it and then show that this was taken away from this. Yeah, however you want to do it. I'm just going to say 42 minus 21. If it's an expression, I don't need to put the equal sign and solve it or anything. Let's look down here now. Marla, Jose, and Sue each wrote a different expression for the blue area. So here's Marla's expression. 1, oh, she did it the way I was thinking the first time. 1 plus 2 plus 3, 4. Jose's expression is take 6 times 7, which would be the 7 across times the 6. So that's your area equals base times height, right? 6 times 7, but the blue is only half of that. So he said divide by 2. Sue's expression is similar. She wants to take half of the 42. So how to write that could be 1/2 times. Remember in fractions, when you multiply, it's like saying of, okay? Half of or multiplied times 6 times 7. So those are 3 interesting ways to think of that one. So number 10, how do you think each student found his or her expression? Are they all correct? Well, yes, they are, and I just went through that. Number 11, simplify each student's expression. They're all going to be equal to 21. All are 21. Number 12, whose expression was easiest to simplify? Well, that's a matter of opinion.